Hello, it is Mrs. McDaniel. I wanted to put 7 notes or 8 notes on roots and zeros of polynomials up. I probably won't do all of these, but I am going to start here at the top. We're going to find roots of polynomials, but we do want to talk about the types of roots and what they are. So rational numbers are numbers that can be rewritten as a fraction or start as a fraction. So like the number 7 can be written 7 over 1. -4 can be written as -4 over 1. 2/3. Then we could also do 6, anything like that. Hang on. Sorry, phone call. So rational numbers can be rewritten as a fraction. Irrational numbers are the ones that cannot. So like pi, somebody brought that up in my 7th hour. It cannot be rewritten as a fraction. It does not repeat with a pattern. 2/3 repeats with a pattern, and that's why it can be rewritten as a fraction. Irrational numbers also are like our square roots, and that's what we see a lot. Like our answers are square root 3 or plus or minus square root 5. So that's what you're going to see a lot as far as irrational. And then complex, we're talking about our i's, like our 6i, our 2 minus 4i. Those are ones that you guys are going to see as far as possible zeros. So zeros in the polynomial, I did want to speak a little bit to multiplicity because that is when there are zeros that repeat. So over here it says the root -3 has a multiplicity of 2. Oh, that's okay. You're good. Sorry, all the interruptions. Anyways, the multiplicity, back to this one. Multiplicity is when it bounces off the graph. So this touches the graph and then it bounces back down. So they count -3 twice. So this is an x squared function. There's a squared at least in it. So that's why it bounces. And then this over here is a multiplicity of 3 because it bends through that number. So since it bends through 0, 0, 0, it has a multiplicity of 3. So that's kind of what the graphs look like when they have multiplicity. So we're going to kind of look at this first one down here, which is find the zeros of the function. And anytime we want to find the zeros of the function, we just set each of our factors equal to 0. Well, just so you know, this x squared is basically x times x. So when I'm saying I'm setting that equal to 0, either the first x can be 0 or the second x can be 0. And that's why that multiplicity y0 is counted twice, because when we set x squared equal to 0, we square root it. And there's no such thing as a negative or positive 0, but it could be the first one 0 or the second one 0. So 0 is our answer twice, or we can say 0 with a multiplicity of 2. So that's one of our answers. Then if we go to another one, we're talking about like x plus 1. If you rewrite that, that's basically x plus 1 times x plus 1 times x plus 1. So technically we could write x plus 1, set it equal to 0 3 times. It could be any of those x's. So we have x equals -1, but that -1 is with a multiplicity of 3. So this is a 0 with a multiplicity of 2, x equals -1 with a multiplicity of 3. And then 2x minus 9 is out there on its own, so we're going to set it equal to 9, or 0, and we're going to add 9, and 2x equals 9, and we're going to divide by 2. So we get x equals 9/2, and that is just a multiplicity of 1. It just passes through 9/2. So that's where we get our 6 answers from. Our first 2 come from the x squared, then we get 3 from the x plus 1, and then we get 1 from that 2x minus 9. So very similarly down here, sorry I kind of ran into this problem, so I'll highlight it so you can see it. X plus 2 is raised to the second power. So that actually, we're going to set it equal to 0. We're going to subtract 2, and we get x equals -2. But that's with a multiplicity of 2. And then same thing over here, 3x minus 5. We're going to set that equal to 0. We're going to add 5. And we get 5/3 when we divide by 3. But that's with a multiplicity of 4, because technically there would be 4 3x minus 5s. So this is with a multiplicity of 4. So we just have to understand that that sometimes happens. And then that last one wouldn't have any multiplicity at all. That would just be a single answer of x equals 4, so it crosses through there. So, all right, moving on down, we're going to take a look at example 2. These we have not really talked about a lot. We're going to write the polynomial function that has the given zeros. So they gave us zeros. So if we have 0 as an answer, that means that x equaled 0. So this is going to be one of our factors, x's, just x. So, and then when we have x equals -3, if you set x equal to -3 and you want to get 0 by itself again, you're going to add 3 over here. So our factored form is x plus 3. So that's our other factor. So we have a factor of x plus 3. And then for half, if x equals 1/2, and we want to figure out what that factor is, we would multiply both sides by 2, and we get 2x equals 1, and then we want to get 0 over here on the right, so we're going to get 2x minus 1 as our factor. 2x minus 1 equals 0, so this is going to be our third factor. So if we want to write it in factored form, it's basically x times x plus 3 times 2x minus 1. Okay, so the other ones, here's something that you need to know. If it is a square root or an imaginary, then it has another imaginary partner to it. So if it's a 2i, that would actually be a plus or minus 2i. Because they always have partners, because you're always square rooting to get an I. So it's always like x squared equals -4 or x squared equals -5. So because this 2i is here, because this 2i is here, this is also going to be a -2i. So I know that's a little bit confusing. We'll talk a little bit more about that in class. But if we want to write this in its factored form, if we have x equals -4/3, then we are going to multiply this by 3, and we get 3x equals -4, and then we add 4 to each side. So our factor is actually 3x plus 4 equals 0. That's how you get -4/3. So it's just doing algebra backwards. And then you actually can leave the 2 i's the way they are. So the factors would be 3x plus 4. And then if the other ones are 2i and -2i, basically you would just subtract 2i over here, and you can write that as x minus 2i as one factor. And then the other factor would be just to add 2i over here. So the second factor would be x equals 2i. Or I'm sorry, not x equals, x plus, 2i equals 0. So the other factor here is x plus 2i. Now, you can multiply the x plus 2i and the x minus 2i out, and the middle terms would cancel, and you'd basically get x plus 4, because it would be x minus 4i squared, and if you remember, I squared is -1. But we're not going to make you go that far. You can just write it like that. So, and then finally, the last one, the -1/3, again, you would say, x equals -1/3, and we would multiply this by 3. So we get 3x equals -1, and if we want to get 0 on that right-hand side, we move the 1 over here by adding. So we get 3x plus 1 for one of our factors. And then the other two factors, because it's I root 5, it does have to have a negative I root 5. So those would end up being an x minus I root 5 and an x plus I root 5. And again, we could multiply those out, but we're not going to make you guys do that. So that's that factored form. Oops. Let's undo that. There we go. Okay. Moving along, you guys, we've got to find rational zeros using graphing calculators. So I did this one in class, and this is just like 6.7, but you would need to find a zero because we did not give you a solution like we did in 6.7. You have to find the solution. So right here, you have to use your graphing calculator or Desmos, but you won't have Desmos on a test to find a zero. I'm not going to go back and forth from the graphing calculator, but you can find the zero. One of the zeros is 2. So when I went into my graphing calculator, I graphed the function, and then I went to second table. And in my table, I saw the table told me that 2, 0 was an answer. So the table told me one of my solutions was 2. So I went ahead and said, okay, well, I'm going to do synthetic division to divide this down a little bit lower. So I got 3, negative 20, 36, and negative 16. I'm going to go through synthetic pretty fast because we've done it a lot. And this is just like what we did the other day. This will be a positive 8, positive 16, and we get a 0 because that is a solution. Now, there's a couple things you can do from here. You can write this out as 3x squared minus 14x plus 8, and then you can factor it because it does factor. You can write it as 3x squared minus 14x plus 8 and use quadratic. Or if you want to, you can go back to your table to see if there is another rational zero, one that is in the table. And that's what we did in class, and we found in the table there was another solution, and I believe that solution was 4. So we went ahead and did synthetic division a second time. So I didn't rewrite this out. I just dropped these coefficients down and did another synthetic division. So I did 3, negative 14, and 8. And my solution was 4, so I'm going to do synthetic division again, and I get 12, negative 2, and negative 8, so I do get 0. So these two are solutions, meaning they are zeros. So I'm going to go ahead, write those over here as zeros, but I should have one more solution left. So I'm going to take what's left over, which this is going to be 3x minus 2, because it's one step down from the x squared. That's going to be our last factor, and we're going to set that equal to 0 and solve. So we get 3x equals 2, divide by 3, so we get x equals 2/3. So that will be our third answer. Now, we should know the linear factors. One linear factor is this guy that you got at the end. That's 3x minus 2. Another linear factor, if you know the solution is 2, if you know this is a solution, its factor has to be x minus 2. Because remember, if x equals 2 and I want to get 0 on the other side, I just subtract that 2 over. So we must have had x minus 2 as a factor. And then our other factor will be x minus 4 because we want to get a positive 4, so it's going to be opposite. So that kind of is what we learned on that first part. All right, I'm going to do one more. I'm probably not going to do the last one because I did it in class, and I want this video to be short enough that you will watch it. So I'm going to do this last one real quickly. I am going to look up the 0 on the calculator, so I put that in. And I look up in the table, and the table gave me a solution equals 2 again on this one. So I'm going to go ahead and do synthetic division, set it up. We have a 1, a -4, a -2, and a 12. We did not skip any values. So we're going to bring down the 1. 1 times 2 is 2. We get -2. Then we get -4 here. So we get -6 and -12, and we get 0. So now we have we basically have 1x squared minus 2x minus 6. And again, on this one, I believe this does not factor any further. And I believe if you looked in your calculator, this does not have any more zeros. If it had more zeros, I would do a second synthetic division, but it doesn't have any more zeros in the tables, so I'm kind of stuck with this as my last factor, and my original factor would be x minus 2, because remember, we divided by 2, so these are my factors I'm going to put down here. But I am going to have to do the quadratic because this won't factor. So I have to do the quadratic. I'm kind of stuck, which is fine. We all know how to do that. So we're going to do the opposite of b, which is going to be positive 2 plus or minus the square root of -2 squared minus 4 times 1 times -6 all over 2 times 1. So when I do that, I believe, and I might go a little bit down into this other problem, you get 4 minus a -24, so you actually get a positive 28. So you get 2 plus or minus root 28 all over 2. And root 28 breaks down to root 4, root 7. And root 4, root 7 is actually 2 root 7. So we get 2 plus or minus 2 root 7 over 2. And then all those 2's can be divided by 2. So it looks like my zeros are going to be 2, and then 1 plus root 7, and 1 minus root 7, because I divide a 2 out of all of them. And those are those irrational solutions that have a root in them, and you cannot find those on the calculator unless you zoom in, and you will get a decimal if you use the boundaries like we did in class. This one we did in class. I will write down the answers for you guys in case you want to go back and check them. But the answers on this one were 2, -1, I root 3. So this one came out as an I root 3 and a negative I root 3. And the factors were x squared plus 3, x plus 1, and x minus 2. I did use synthetic division twice on this one because there were 2 zeros that I could see on my calculator. And if you want to do this one on your own, if you don't have a calculator, you can look on Desmos, but the 0 from the table, the solution that I used was 2. So you can do this one, or I did it in class. You can grab it from somebody else if you want to see it. But I'm going to call it there and stop it. So hope you guys have a great day, and we'll talk to you soon. Bye.